Hello guys, welcome once again. In our last video we looked at the structure of the atom. Today we are going to understand what the atom entails. We're going to look at mass number and atomic number. So as we said in our last topic, in our last video, an element is a pure substance which cannot be split into anything simpler or simple by any chemical means. So an element is a pure substance which cannot be split into anything simpler by any chemical means. We have elements, for example, sodium. Sodium symbol is Na. We have magnesium. We have sulfur and we have phosphorus. Those are examples of elements. We can have oxygen is an element, but it exists as molecules. So oxygen is also an element, but it exists as a molecule. An atom is the smallest particle of an element that takes part in a chemical reaction. So this is what we are looking at in an atom. So an atom is the smallest particle of an element that takes part in a chemical reaction. And we said that an atom consists of subatomic particles, which include protons found inside the nucleus, and they are positively charged. We have neutrons inside the nucleus. They have no charge. We have electrons, which are in the energy levels outside the nucleus, and they are negatively charged. So an atom is made up of two regions. Number one, the small central region known as the nucleus, where protons and neutrons are found. Number two, we have the energy levels where electrons are distributed. So you can see how I've sketched the structure of the atom. The nucleus in the middle, and we have which has protons and neutrons, and we have the electrons in the energy levels which are outside the nucleus. For an electrically neutral atom, now that we know what's an atom, for an electrically neutral atom, the number of protons is equal to the number of electrons. So an atom that has not lost or gained electrons, protons are equal to electrons. So it's known as an electrically neutral atom. So protons are equal to electrons in any atom that is electrically neutral, that has not lost or gained electrons. So under that, in an atom now, we want to know what is mass number. Mass number of an atom is the sum of protons and neutrons in an atom of an element. So mass number is the sum of protons and neutrons in an atom of an element. For example, sodium has 11 protons and 12 neutrons. So therefore we can calculate the mass number, where we can say mass number is equals to P plus N. P is protons and N is neutrons. So P, when you add 11 plus 12, the mass number of sodium becomes 23. Another thing that you need to know is atomic number. What's atomic number? Atomic number is the number of protons in the nucleus of an atom. So the protons in an atom is the atomic number. For example, sodium has 11 protons, therefore its atomic number is 11. Phosphorus has 15 protons in the nucleus, so therefore the atomic number of phosphorus is 15. Aluminium has 13 protons in the nucleus, therefore the atomic number of aluminium is 13. Neon has 10 protons in the nucleus, therefore its atomic number is 10. And now mass number and atomic number can be written alongside with the symbol of the element. Mass number is written as a subscript in front of the chemical symbol, i.e., for example, in sodium, mass number is 23, so it's written above before the symbol of the element, so which is known as the subscript. Where the atomic number is written as the subscript in front of the chemical symbol. You can see sodium has 11 protons and the atomic number is 11. So it can be, therefore the element is represented as, we have sodium, we have mass number is written as the superscript, and the atomic number is written as the subscript. So mass number is written as the superscript and atomic number is written as the subscript. When you subtract a mass number from the formula, mass number is equals to protons plus neutrons, you want to find protons, which is also the protons is the atomic number, remember. So if you take neutrons to the other side, therefore finding neutrons is mass number minus protons, so that you can have neutrons. So neutrons remaining the other side, taking protons to the other side using mathematics, mass number minus protons, and remember protons is atomic number, you find neutrons. So therefore it means that when you have an symbol of an element alongside with mass number and atomic number, you just subtract 23. For example, in sodium, mass number is 23 and atomic number 11, you get the number of neutrons. So that is the relationship when you have that. Now, for example, we have a question here. We have lead has a mass number of 207 and atomic number or the number of protons is 82. To get neutrons, therefore, you subtract 207 minus 82, you get 125 neutrons. Therefore, the nuclear composition is as follows. It has 82 protons. Protons, remember, is the same as atomic number here. It has 125 neutrons. These two are found in the nucleus, but electrons are distributed in the energy levels. So therefore, for lead, mass number is 207, atomic number is 82. To get neutrons, you just subtract 207 minus protons, which is 82, which is atomic number, to get 125 neutrons. So the nuclear composition is 82 protons, 125 neutrons, and 82 electrons. For zinc, mass number is 65 and protons or atomic number is 30. So to get neutrons, you subtract mass number minus protons, which is 35 neutrons. So therefore the nuclear composition is 30 protons, 35 neutrons, and 30 electrons. Therefore, points to note are as follows. For an electrically neutral atom, protons is equal to electrons. For an electrically neutral atom that has not gained or lost, protons is always equal to electrons. Mass number is protons, you add neutrons. So P plus N. Protons plus neutrons, you get mass number. Protons plus neutrons, you get mass number. And protons is equal to electrons for an electrically neutral atom. And finally, atomic number is the number of protons in an atom of an element. So therefore, atomic number is equal to protons. We have an example here. Element X has 31, mass number of 31 and 16 neutrons. Find its nuclear composition. So if it has the mass number 31 and 16 neutrons, find its nuclear composition. Therefore, it will be mass number plus is equals to protons plus neutrons. Therefore, protons, how can we find protons, which is also atomic number, is mass number minus neutrons. Doing it, it's 31 minus 16, you get 15 protons. Therefore, nuclear composition is 15 protons, 16 neutrons, and 15 electrons. That is it. That is it for that. So we should know the relationship between protons, neutrons, mass number, and electrons, and atomic number. That is the relationship. You must know that. And let's go to now, what is electronic arrangement? Now that we have said protons is equal 2 electrons for an electrically neutral atom. So we want to talk about electronic arrangement. This is very important. Electronic arrangement. In grade 10, we look at electronic arrangement in terms of orbitals. But in this 844 system, we are going to look at electronic arrangement in terms of energy levels. How? In these energy levels. In grade 10, it's about S, P, D, and F orbitals. But in this case, we're going to look at using configurations. So, in what is electronic? Is the distribution. Electronic arrangement is the distribution of electrons in the energy levels of an atom. For an electrically neutral atom, atomic number is the same as protons, is the same as electrons. That is it. So, in an atom, the first energy level, you can see maximum electrons that can occupy. After the nucleus, we have the first energy levels. The maximum electrons that can occupy the first energy level is 2. The second is 8. The third is 8. The fourth, because we are talking about the first 20 elements, we don't go much to the fourth energy levels. For 20 elements, we have only 4 energy level. First energy level, maximum 2 electrons. Second energy level, maximum of 8 electrons. Third energy level, maximum of 8 electrons. Fourth energy levels, we don't dwell much on that. We have an example here. Element W has a mass number of 27. So mass number is 27 and atomic number is 13. Draw the atomic structure of W using dots or crosses. So when you use the relationship of mass number, atomic number, and neutrons, you get that mass number is equals to protons plus neutrons. Therefore, to get neutrons, it is mass number minus protons, which is the same as atomic number. So 27 in this case is the mass number. When you subtract with atomic number 13, you get 14 neutrons. So we have 14 neutrons. So therefore, using the electrons that are present, we have 13 protons. If we write the nuclear composition, we have 13 protons. 13 protons because it's the same as atomic number. Protons are equal to atomic number because atomic number is the number of protons in an atom of an element. So 13 protons are in this element W because the atomic number is 13. 14 neutrons. When you subtract mass number minus atomic number or protons, you get 14 neutrons. So we have 14 neutrons and 13 electrons. 13 electrons because for an electrically neutral atoms, protons is equals to electrons. So we have 13 electrons. These 13 electrons are the one that we use to write the configuration. So we can use atomic number, protons, or electrons for an electrically neutral atom to write the configuration. So therefore, the configuration of this element is 2:8:3. 2 electrons will enter the first energy level. If the 2 electrons enter the first energy level, we have remained with 11 electrons. The second energy level will take the 8 electrons. So 11 minus 8, we find 3. 11 minus 8, we find 3 electrons. So the second energy level is full. The 3 electrons go to the third energy level, which is not full. So we have 3 electrons going to the third energy level. And when now we are drawing, this is very key. We are drawing the structure of the atom. We draw the nucleus. Because we had protons and neutrons, we place them inside the nucleus using the number. You don't just write the symbol of the elements when you are given. When you are not given these all things above here, 27, 13, you can just write the symbol of the element. But when you are given, write 13 protons because element that W had 13 protons and 14 neutrons. So after that, you go to the first energy level. First energy level contains 2 electrons. Second, 1, 2, 3, 4, 5, 6, 7, 8. So the second energy level is full. Then we go to the third energy level, 1, 2, 3. So we have 3 electrons in the last energy level. And by the way, using this, a period and group of an element can be determined from the electronic configuration 2:8:3. So looking at the group, you look at the number of electrons in the outermost energy level. For example, element W is in group 3. You use the Roman numbers because is in group 3 because it has 3 electrons in the outermost energy level. So it's in group 3. So we use configuration to know the group and period. So group, it's in group 3 because it has 3 electrons in the outermost. And period, we look at the number of occupied energy level. We have 1 occupied energy level, 2 occupied energy level, 3 occupied energy level. So it's in period 3. And the reason is that it has 3 occupied energy levels. It has 3 occupied energy level. Therefore, writing an electronic arrangement is very useful, very important in determining the structure of the atom, the group of the element, and the period of the element. Let's go to the last question on that. We have phosphorus is an nonmetal with a mass number of 31 and atomic number of 15. So draw the atomic structure of P, phosphorus, and its nuclear composition. So phosphorus mass number is 31. When you subtract with protons or atomic number, you get 16 neutrons. So nuclear composition is 15 protons because atomic number is 15. 16 neutrons because neutrons, you find neutrons from the formula. Mass number is equals to P plus N. So mass number, we have mass number, we don't have neutrons. So protons is the same as atomic number. So finding neutrons is mass number minus protons or atomic number. So mass number is 31 minus atomic number is 15, or protons is 15, you get 16 neutrons. That's how we go about it. So the composition is 15 protons, 16 neutrons, and 15 electrons, because for electrically neutral atoms, protons is the same as electrons. That is it. And when you draw the structure, the configuration is 2 electrons will go, 15 minus 2 will go to the first energy level, remain 13. 13 minus 8 will be 5. 5 will go to the third energy level. So 2 will occupy the first, remaining 13. 8 will go to the second, remaining 5. 5 will go to the third energy level. So that is it here. So 2 electrons in the first energy level. So first we have the nucleus, protons and neutrons in the nucleus. We have 2 electrons in the first energy level. 1, 2, 3, 4, 5, 6, 7, 8 in the second. And 5, 1, 2, 3, 4, 5 in the third energy level. Using configuration 2:8:3, 2:8:5, sorry, it has 3 occupied energy levels. Therefore, it's in period 3. So, it's in period 3. This element is in period 3. Why? Because it has 3 occupied energy levels. 1, 2, 3. 3 occupied energy levels. 1, 2, 3. 1 first energy level, second energy level, third energy level. So we have 3 occupied energy level, therefore it's in period 3. And it's in group 5 because it has 5 electrons in the outermost energy level. Let's count the outermost energy level. 1, 2, 3, 4, 5. So it has 5 electrons in the outermost energy level, therefore it's in group 5. So therefore, if you are asked to which group and period do an element belong to, look at period, you look at the number of occupied energy level. If there are 3, you say period 3 because it has 3 occupied energy levels. But if they have asked you group, you must write the group in Roman numbers. Group 5, for example. Group 5. Why? Because it has 5 electrons in the outermost energy level. And what are ions? After knowing an atom, you should know what's an ion. Very important in chemistry, in electrochemistry. It's very key for you to understand an ion. It's very key to understand what's an ion. So ions are charged particles formed when an atom loses or gains electrons. So elements that do not have a stable electronic arrangement can either gain or lose electrons because they are not stable. So they form ions. So atoms with electronic arrangement 2, that is helium, 2:8, that is neon, 2:8:8, that is argon, are said to be stable since they neither gain or lose electrons. So therefore, these elements do not form compounds because they are stable. They neither gain or lose electrons. Elements react because they lose and gain electrons. What makes, by the way, elements to react is either gaining or losing of electrons. Atoms without this electron arrangement tend to attain stability by losing or gaining electrons. Metal mostly lose electrons to form positively charged ions known as cations, while nonmetals tend to form negatively charged ions known as anions. For example, we have sodium atom. Sodium atom loses an electron to form sodium ion. So this is 2:8:1. This is 2:8. It has lost 1. Magnesium loses 2 electrons to form magnesium ion. So magnesium atom loses 2 electrons to form magnesium ion. This is 2:8:2, and this is 2:8. Oxygen is a nonmetal. It gains. It takes the 2 electrons. Therefore, it forms an oxide ion or oxygen ion. So this is 2:6 and this is 2:8. Chlorine is a nonmetal. It gains 1 electron to form a chloride ion. So this 2:8:7 and this 2:8:8. So it has gained stability. This has gained a stability of 2:8:8, and this has gained a stability of 2:8 from 2:6, and this is 2:7. 2:8:7 has gained 1 electron to form a chloride ion, and magnesium is 2:8:2 has lost 2 electrons, these 2 electrons in the outermost energy level, to form 2:8. And sodium 2:8:1 has lost 1 electron to form 2:8. So sodium loses 1 to form an ion known as sodium ion. So 2:8:1, it forms 2:8. Electron configuration such as that of neon. Magnesium loses 2 to form an electron arrangement such that of neon. Oxygen gains 2 to form an electronic arrangement such as that of neon. Chlorine gains 1 electron to form an electronic arrangement like that of argon. So thank you.